this is a video on how to graph from factored form. So if we look at the instructions, it says for the given equation below, put the equation in factored form, find the x and y intercepts, the axis of symmetry, the vertex, and sketch the graph of the equation on the given axes. Make sure to have found at least 3 points. And then this is the point breakdown that you will get on the test according to how many points you got within this section. So first off, let's look at the direction of opening. So on the direction of opening, I would say, well, like this is A is -3, and that means that this opens down. And so that is because A is equal to -3. The fact that it is negative means that this opens down. All right, factored form. So on this, the first thing that I'd want to do is factor out. So remember, there's 3 factoring strategies. Greatest common factor. 2 is dos. That's 2 terms. Difference of squares. This is not 2 terms, so that doesn't apply here. And then 3, the trinomial. And so we are going to end up using both of these. This one and this one. We're going to factor out first the greatest common factor, and because our leading coefficient is negative, we're going to factor out a negative. So that's the first thing. I'm going to factor out -3. These are all multiples of 3, so I can factor 3 out of all of them. So that's going to be -3 times x squared. Now, as I do this, there's going to be 2 more terms here. I know that -3 times x squared would give me -3x squared. So that's good. Then I had to say, I look at this kind of step by step. I say, what would I multiply by a negative so that I get a positive on this next term? Well, it would have to be a negative, because a negative times a negative is positive. And then I'd say, well, what would I multiply by 3 to give me 12? And that would be 4. And if I just leave it like that, -3 times 4 is positive 12, but it needs to have an x, so -4x. And then, once again, I'm going to do the same thing. What would I multiply by this negative? -3, so that works there. And then -3 times what would give me negative on this -9? That would have to be positive. And then 3 times what would give me 9? Well, 3. So -3 times a positive 3 is -9. Now, now that we've taken this out, now I can look at that A here is 1, B is -4, and C is 3. This is not a great place to put those. I'm going to erase that. But I still want to have that. So A is 1, B is -4, and C is 3. Because A is 1, then I can just jump straight into the factors here. So I'm going to say, okay, I've got -3. Let's go ahead and bring down this f of x. I'm going to call it y. Y equals -3, and then open up 2 sets of parentheses. And I know that the first terms in each of those parentheses has to be x, because x times x would give me the x squared. And then I also know that these 2 numbers have to multiply to give me a +3, but they have to add to give me -4. And so I know that both of the numbers have to be the same sign, and they both have to be negative. So I'm going to put the signs in here, negative and negative. And then because 3 is prime, it only has 2 factors, 3 and 1, so I put 3 here and 1 here. And once again, I'm just going to kind of show how we would check this. X times x would give me x squared. Yes, that right there. X times x is x squared. And then x times -3 would give me -3x. And then x, -1, I've multiplied x by each of those. -1 times x would give me -1x. And then, let's see here, finally, -1 times 3 would give me a positive 3. These two combine to give me that negative 4x, and then the 3 is there. So those are this is factored correctly. Now, factored form, here we go. Y, you could also write f of x, it's the same thing. Negative 3 times x minus 1 times x minus 3. And so my x-intercepts come from the fact that I've got 1, 2, 3 things being multiplied. And for x-intercepts, remember y equals 0. So I'm going to bring this down here, y, but instead of y, I'm going to call it 0. 0 is equal to negative 3 times x minus 1 and x minus 3. This negative 3 is not going to affect the solution. It could be anything. As long as it doesn't have a variable with it, it's not going to change the solution. What will change? These factors that have the variable, because those values can change, and we need them to be 0, because only multiplying by 0 can you get 0. So I get x minus 1 equals 0, or x minus 3 equals 0. And then here, this would imply then that x has to be 1, because 1 minus 1 is 0. And here x must be 3. And so my x-intercepts, I'm going to take those values, 1 and 3, and put them with the corresponding y values where y is 0. So this is 1, 0 is one of my x-intercepts. The other x-intercept is 3, 0. So I'm going to graph these. Here is 1, 0, and here is 3, 0. I think it's a good idea for you to label these, especially if you're not super confident in your abilities to graph. Labeling them is a good idea. So there's 3, 0, and there is 1, 0. Now, there's two ways then to think about where the axis of symmetry is. You can count the spaces. There's 1, 2, and half of that is 1. So then I can just find the place in the middle. And so this would be, this vertical line here would be my axis of symmetry. And so I'm going to label it up here. I'm just going to put AOS, that's axis of symmetry, and that's the line x equals 2. The other way that you can do this is just average the x values. So I take 1 plus 3, those values right there, 1 plus 3, and when you're taking an average, you're finding the middle value. So 1 plus 3, there's two numbers, so I divide by 2. 1 plus 3 is 4, divide by 2, and that is 2. So x equals 2, which is what we got here. Now, what we have just found then is the axis of symmetry. That is x equals 2. And if you would like, you can just say, I took that 1 and that 3. 1 plus 3 divided by 2. 4 divided by 2. 2. Remember that it is an equation. It's x equals 2. It wrote this as a reminder that the axis of symmetry is an equation, and it's always x equals some number. Now, we need to find the vertex. So the vertex is going to be somewhere on this line, and this is where we bring in the whole plug and chug thing. So for the vertex, x equals 2. Now, we can plug that into the original equation in standard form, or we can plug it into the equation in factored form. If we have factored it correctly, it shouldn't matter. You can plug it into either place. And if you plug it into both, that can help verify that you did factor it correctly. So x equals 2. I've got f of 2. I'm going to use the factored form, at least first. Negative 3 times 2 minus 1, and then 2 minus 3. And so that's negative 3. 2 minus 1 is 1, and 2 minus 3 is negative 1. Because I have two negatives, when I multiply those, I'm going to get a positive. So this is going to be 3 times 1 is 3, times 1 is still 3. So f of 2 is equal to 3, which means my vertex is at the point 2, 3. Now, I mentioned that we can plug this into the standard form and get the same value. So if I do that, I've got negative 3, then parentheses x, which is 2, squared. That's my negative 3x squared, plus 12x, plus 12 times x, which is still 2, and then minus 9. Minus 9. And when I hit enter, I want to see that it has that same value that we found just now, which was 3. Sure enough, we got 3. So you can verify that you have factored it correctly in that kind of a way. So the y-intercept is the easiest thing we get from standard form, because it is already in standard form. It's always the c value, and so it's 0, negative 9. Now, if you had wanted to, you can go back and plug that in. Here, this would be 0 and 0, and so I'd say, well, what does this look like if x is 0? So I just put 0 here and 0 here, and that would give me negative 1 here, and 0 minus 3 is negative 3. I've got 3 negatives. If you have an odd number of negatives in a multiplication, your answer is odd. So this is negative. 3 times 1 is positive 3, and then positive 3 times negative 3 would be negative 9. Which, again, same as we got from standard form, but it was much easier to do in standard form. Okay, let's see. So let's graph these points. 2, 3. 2, 3. So this right here, 2, 3, and that's my vertex. And my y-intercept is down here at negative 9. This is negative 6, negative 7, negative 8, negative 9 would be down here. And it's 2 units from the axis of symmetry, so I go over 2 units on the other side, and there is some points there. So I can graph this by saying here this goes up here and through this point, and then down through that point, and then down through that point.
If you are
and so
not already on your way down to Mark
this
Taylor's
is what
Flyer Road, if you'll please do that.
this is what this looks like.
We can gather, and then we can get out of here.
You got this. Study. You got it. Keep working hard.